Region A. Let's start with the analysis of the NMOS transistor. First, we need to determine whether the NMOS transistor is turned on or turned off. To determine this, we need to know 1. NMOS gate source voltage. 2. NMOS threshold voltage. At the inverter's input, the NMOS gate source voltage is defined as the inverter's input voltage. The region in green indicates the NMOS gate source voltage. By visual inspection, the NMOS gate source voltage is lesser than its threshold voltage. Therefore, we can see that the NMOS transistor is operating in the cutoff region. Next, let's proceed with the analysis of the PMOS transistor. First, we need to determine whether the PMOS transistor is turned on or turned off. To determine this, we need to know 1. PMOS gate source voltage. 2. PMOS threshold voltage. Based on the KVL analysis at the inverter's input, we know that the gate source voltage of the NMOS plus the gate source voltage of the PMOS will be equal to VDD. Since we know that the gate source voltage of the NMOS is the region highlighted in green, the gate source voltage of the PMOS will be the region highlighted in orange. As we know that the threshold voltage of the PMOS transistor is defined as VDD plus VT not P. Therefore, the threshold voltage of the PMOS transistor will be the region highlighted in brown. By visual inspection, we can see that the PMOS gate source voltage is much greater than its threshold voltage. Therefore, we know that the PMOS transistor is turned on. Up till now, we only know that the PMOS transistor is turned on. To complete the analysis of the PMOS, we need to determine, is it operating in the linear or in the saturation region? To determine this, we need to know 1. PMOS gate source voltage. 2. PMOS threshold voltage. 3. PMOS drain source voltage. Since we already know the first two parameters, we will determine the PMOS drain source voltage. According to the IV characteristic, the drain source resistance is inversely proportional to gate source voltage. By visual inspection, we can see that the PMOS gate source voltage is much greater than the NMOS gate source voltage. Therefore, we can say that the NMOS drain source resistance will be much greater than PMOS drain source resistance. At the same time, we also know that the NMOS transistor is turned off. With this information, we can conclude that the inverter's output voltage will be equal to VDD. If the inverter's output voltage is VDD, the drain source voltage of the NMOS transistor will be VDD as well. Based on the KVL analysis at the inverter's output, we know that the drain source voltage of the NMOS plus the drain source voltage of the PMOS will be equal to VDD. Since we know that the drain source voltage of the NMOS is equal to VDD, the drain source voltage of the PMOS will be equal to 0. Therefore, we can conclude that the PMOS is operating in the linear region. In region A of the CMOS inverter, the NMOS transistor is in the cutoff region. The PMOS transistor is in the linear region.